Hi, this is Mr. Heineman from Evergreen High School. This is for my Algebra 1 students. This is from Unit 6, Rational Exponents, Exponent Properties. So we're talking about more exponent properties, and one of the exponent, or a couple of the exponent properties that kind of are very, very similar are the power of a product and power of a quotient. And how those work is that the power of a product or a quotient, you're going to see parentheses. And if there's more than one term inside a set of parentheses with an exponent that's outside, then that exponent is distributed to every term that's in the parentheses. Okay, and it applies when there are both multiplication and division involved. So it doesn't matter whether you're doing products or quotients. If there's stuff inside of parentheses and a exponent outside of parentheses, you give every term in the parentheses the exponent. So let's do some examples. We'll start with just this simple one. This is just a product property, but we also have a number there, and sometimes when the number is there we get a little confused, but really the only thing we're going to do is write the number because there's no other numbers to multiply it with, and then we'll just multiply the terms that have a common variable. So we can multiply x squared and x to the third. We know that's x to the fifth using the product property. Okay. In this one though, this one is a product of a quotient and a power, because we have a 3 outside of a set of parentheses, so everything inside, the 5, the x on top, and the x on bottom all get the exponent. Oops. Rewrite my 5. Now I can do the next part. Well, x to the third and x to the third are going to cancel. I'm not even going to do a quotient property on that one. I know they're going to cancel. And then 5 to the third is 5 times 5 times 5. I know that's 125. So I can just rewrite that as a number. Finally, with this one, where we have 3w to the fourth squared, we're going to go ahead and do that. I have 3 squared, and then w to the fourth, that also is squared. So we distributed the 2 to everything inside, and then I got to do a power of a power property with the w to the fourth to the second. I'm going to go ahead and just figure out 3 squared is 9, and then w to the fourth to the second is w to the eighth. So another property that we need to know about is the negative exponents property. And when there's a negative exponent, this means we're going to flip the base from either the numerator to the denominator or the denominator to the numerator. If there's not a fraction, then the denominator of that term is 1, and the new fraction will now have a numerator of 1. So we move the numerator, which in this case doesn't look like a fraction, but you take that number, that term, and you put it on the bottom of a fraction and put that over, put 1 on top of that. Another property that we need to know about is the zero exponents property, and anything that is raised to the power of 0 is equal to 1. It doesn't matter what the base is, only that the exponent is 0. So it could be a huge base number, but if it's raised to the 0 power, it's 1. Unless the term with the 0 exponent is the only one in the numerator or the denominator, then it kind of just disappears, because when we multiply by 1, nothing changes. So when it comes to the numerator or denominator, if that's the only term that we have that is a 0 exponent, then we can write 1. Otherwise, the term just kind of disappears, and we just write whatever terms are left over. So in this first example, I'm going to look at x to the negative 3. And so that I think of this like a fraction, I'm going to make it a fraction over 1. That way I know that when I use the negative exponents property, we're going to flip this fraction. And we call that the reciprocal when we flip a fraction. So, and I flip the fraction so that I can rewrite the base with a positive exponent. So I can write it as 1 over x to the third instead of x to the negative 3. They're equivalent expressions. when I have other properties involved, I generally choose to do all the other properties first, and then if I need to at the end, use the negative exponents property. So this is, again, it's a personal thing. So I'm going to distribute this -2 to everything in here because that's what the power, or the power of a product or quotient property is. So that means I'm going to do x to the third raised to the -2, y to the -2, all of that over x to the -2. And then I'm going to simplify using other properties. Power of a power property, so that's x to the -6, y to the -2, and then x to the -2 here. And then I can simplify using the quotient property. -6 minus -2, well, that's like -6 plus 2, so that's -4. And then still have y to the -2. And since both of them are negative, I need to put both of them on the bottom of a fraction. So I treat this like a big old fraction. And we're going to turn this into 1 over x to the 4th y squared. And now we've written it with each base to one positive power. Continuing on with the examples, I'm going to take this, and we're first actually going to go ahead and do the quotient property. And the 4 is just going to stick around, it's not going to do anything. And then when I do the quotient property, I have a 1 here, so I have x to the 1 divided by x to the 5th. 1 minus 5 is -4. And now that I have it in this form, I can rewrite it one more time using the negative exponent property. But this time only this term gets flipped, because the 4 doesn't have a negative exponent, it's just a number. It's going to stay on top, and then the x to the 4th will go on the bottom. So 4 over x to the 4th. If I do a similar one and apply the quotient property here, this is kind of like one we saw earlier. I have 4x to the 0 this time though, and I know x to the 0 is 1, and so I really have 4 times 1, which is just 4, and I'm going to write 4. X to the 0, y to the 0, 258 to the 0, doesn't matter, they're all 1. So since I just have 4 times 1, I'm just going to write 4. So the thing is, when it comes to doing exponent properties, we almost never see them just by themselves. We usually see them in combination with other properties. So for instance, we have one big set of parentheses raised to the second power, and then we have a bunch of stuff inside. 3x y squared z cubed, and then all of that raised to the second power. So I'm going to work from the outside in and apply ones I've learned before and ones I've learned now. So the first thing I'm going to do is the product of, or the power of a product property, where I'm going to distribute this 2 to everything inside. So that means 3 squared, x squared, y squared squared, z cubed squared. And then I can apply other properties as I need to. 3 squared, I'm going to go ahead and rewrite that as a number, that's 9. X squared is just x squared. Y squared squared, I multiply those two because that's a power of a power property. And then z cubed squared is another power of a power property, so that's going to be z to the 6th, because I multiply 3 times 2. And I can leave it like this because I've simplified it so that all of the bases are written with 1 power each, and numbers are written. You could leave them as powers. I usually calculate them out and figure out what they are. And they're all raised to positive powers, and that's also an important thing, that we should try and raise them to positive powers and leave them as positive powers. I also write them in alphabetical order, just so I know which ones I have. So I'm going to continue with this example, and we've got x cubed y over x raised to the second power, and I'm going to work it all from the outside in again. So I'm going to first do my quotient of powers property and raise the top of this fraction to the second power and the bottom to the second power. But then I notice here this is a power of a product property, so now I'm going to distribute the 2 to each of those. So I get x cubed squared y squared over x squared. And then I have a power of a power, so that's x to the 6th y squared over x squared. And now I can match these two up because it's a quotient of powers property, and I have x to the 4th y squared is the final answer. So I started with the quotient or a power of a quotient property, and then a power of a power, or power of a product, then a power of a power, then quotient property. And I finish with x to the 4th y squared. And even when using negative exponents, what we do, and what I do, is just I do all of my other properties first and save the negative exponents for the last part, because I only want to really deal with that if I have to. So we do the quotient, or the power of a quotient property, I should say, and distribute the negative 2 to both the y, or the x and the y on top, and the x on the bottom. And then, and I skipped a property here, but from the last example you remember that when I have multiple things on top, I just do the power of a product property as well. So I did power of a quotient and power of a product property to get both parts of the top their own exponents, because I have to do both top and bottom for the quotient property, and then both parts of the top for the power of a product property. And then I use a power of a power here. Well, negative 2 times negative 2 is a positive 4. And then I can do a quotient property with the two x's. So that's 4 minus negative 2, which would be 6. And now I'm going to deal with the negative exponent of y. I'm going to move it down to the bottom of the fraction. And now I can turn it to positive. So I have x to the 6th y squared. That's it. Good luck working on the word game today.